two cabinets. You have cabinet A and cabinet B. And you want to maximize, I'm just going to call it P for profit, it doesn't matter. You want to maximize the storage capacity of that. I believe cabinet A, correct me if I'm wrong, was 12 cubic feet and 16 cubic feet? 18, thank you. So it's 12 cubic feet and 18 cubic feet. You want to maximize your storage capacity. How much junk can you fit in the room? Okay. Now, it also gave you two constraints.
Wait, I'm sorry, this is
22.
22?
It talked about two things. It talked about square footage. Alonzo, he thinks he's a big man. He's a punk. It talks about two things. It talks about square footage and it talks about cost. You have X amount of square footage to combine them. It tells you about the what's called the footprint of the cabinet. How many square feet does it actually take up when you put it on the ground? Cabinet A had a square footage of, I think it was 6 and 3, if I'm not mistaken. A was 6, B was 3.
No, A was 3, B was 6.
8, 3, and 6. Thank you. I've only used this book for like 8 years, so you'd think I'd memorize all the problems by now.
I thought you said this was a new book.
This is the old book.
Wait, isn't it 3A plus 6B is less than or equal to 60?
Exactly.
Okay, I did like half of it, but I couldn't see it.
Okay? Because that talks about your floor space. Yes, sir.
I just thought about it, and then I'm like, wait, you only need like 10 of cabinet B because it was bigger and it cost less, and it took up like all of the space.
Well, we'll see how that works out. So you might be careful. There could be a combination. And then the other one talked about money.
So then the money one, 75A plus 50B is less than or equal to 600?
Perfect. 60B?
Yeah, 50B.
50.
Like I did it right, but like I did it.
Can you have negative cabinets?
No.
No. First quadrant problem. We have first, actually, I'll do this. More space. First quadrant problem. We have A, B. Cover and solve. 20 and 10.
Wait, what? For which one?
First one. This is my A. This is my B.
Well, you got 20 and 10 from the 75.
I'll do this one.
From the
Top first equation. Did you write 75 first? I'm doing the first question. 3A equal to 20, equal to 60 is 20, 60 is that's what
I like, instead of like doing like descriptive thing, I put like A is less than or equal to 12 or something, and then like.
And then I did the same thing with the other one. 75, so it's 4. No. 8, thank you. 8 and 12. So we have 4 points to check. 0, 10, 8, 0, 0, 0. Bless you. And then the intersection of this one. The quickest way to, bless you, the quickest way to do the intersection of that one is you can, I don't know, just say that A plus 2B is, if I divide everything by 3, A plus 2B is 20. So A is 20 minus 2B. You can do any linear combination, any type of method on that one. All I did there is divide everything by 3, and then I'm just going to substitute in. So if I do that, it's, remember when we did all the system of equation stuff at the beginning of the year? That's what we did. 50.
Okay.
All right. Distribute out 150, 1500 minus 150 plus 50, 600. I'm going to bring this over so I get 900 is 100 B. If 9 is B, what's A? 2. divided by 100. Bless you.
Oh, thank you.
Yeah, but then how'd you get,
I just substitute back in because a plus 2b is 20. 9 times 2 is 18. 20 minus 18 is 2. And it works out that this ordered pair of 2 and 9, that's your maximum. Yes, ma'am.
At the top of that equation, the 20 minus 2b, did you just get that from the a plus 2b?
Yes.
And then you just
Yep. Yeah, you can do any type of linear combination with that one. Whenever I see stuff that I can easily get in terms of one variable, I use substitution a lot. That's just my own personal preference. It doesn't make a difference if you go with a scalar multiplier and add or anything like that. It's totally up to you. I see things like that and I just go, oh, I would do that. Sorry.
The answer that I got wrong then?
Yeah. That's why I said it. Sometimes it works.
Wait,
Yes, ma'am.
so how were you in the first place able to get a plus 2b equals 20? Like, what was it?
All I did is I took 3a, 6b is 60, divided everything by 3.
Oh, okay.
And I just,
Oh.
in my mind, when I see GCFs, I take them out and I move things fast. I have always thought that was the quickest way to do it. That's my own preference. I could have multiplied it by 25, subtracted it from the other one, and done that also. It would have worked.
Okay, so then what would the shading mean?
Everything's moving inward. Because everything's less than or equal to it. So 0, 0 is always less than that, so it's always moving inward.
Okay, so then, like, would you just shade, like, all of that?
The overall overlap area would have been just in here.
Okay.
All right.
And what would be all the points that you would use? You would use 0, 10, 0, 0, 8, 0, 2, 9?
Yes, ma'am.
Oh, you wrote that.
Orange aid and berry fruity. Remind me at the end of the school year to retype that into language that makes sense. I do apologize that the way that it's worded is talking about an orange aid drink that uses orange juice and a berry fruity drink that uses orange juice and raspberry. So it kind of gets mixed up on what you're, not get it mixed, kind of gets messed up in terms of what goes with what. So to be honest with you, 21, once you understand the linguistics of it, is pretty easy. 23 just sucks. All right? Just so you know on that one. So when I look at, let me get through this because I don't have much time. Tomorrow when we quiz is a couple word problems, a couple of graphs, nothing too fancy, nothing too crazy. It should be a softball toss. Sir.
I also wanted this work, but I know that it's wrong because I have access.
So in 21,
Just have access.
guys, we only have a few minutes here, okay? In 21, if you read through it, it gave you a cost of a profit you wanted to maximize, and you made 50 cents per, what was it, raspberry? Or no, 50 cents on an orange aid and 40 cents on berry. So we want to maximize our profit of 50 cents. And here's where things get weird how I type it. Instead of using O, I'm going to use OR.
Could you use G?
Sure.
See, I got this far.
Okay.
And then I kind of lost it.
Here's where it gets messy then. You have restricted on the number of gallons of juice you have to mix. You have orange juice to mix. You have 125 gallons of orange juice. And you had 150 gallons of raspberry juice to mix. And you just figured it out. Because one drink uses this much of the orange, the other one uses this much of the orange, the other one uses this much berry, and this much berry. That's the restriction. So what you have to do is that they're talking about it in terms of quarts and gallons. Your easiest conversion when you're doing stuff like this is always to convert backwards. Go to the smaller conversion. Because how many quarts are in a gallon? 4. So multiply both of these by 4, and you get 500 quarts and 600 quarts. I can use, it's not going to work. You could divide the other ones by 4, but you're dealing with weird decimals at that point.
Oh, that's right.
It should work if you did it right. It's just nasty.
Yeah.
Okay. So if I'm looking at what's being used in the orange juice mix, The one of them uses 2.5 quarts for the orangeade, and the berry fruity one uses 1 quart of it.
So that's so much easier to do. Is I didn't know.
That-
Okay.
That's for the berry. That's for the raspberry part.
No,
What I was
it's
trying to
1.5,
No,
it
it's-
makes a whole gallon.
It's not.
I don't know what to do.
I'm looking at it in terms of the orange juice. The orange juice for one of them uses this much, the other one uses this much, 1 quart. The other one is 1.5 of the berry in here. The other one uses 3 berry in that one. Yes, ma'am.
So just to make it easier, you just multiplied it all by 4 because like the other two, they're over 4, so then you
Yeah.
just multiply them by 4.
Yeah.
And the other side, of course.
Yeah, because they're already, since one side's already in quarts,
Yeah.
it's easier to work with. Because if I have gallons, then I would have to divide 2.5 by 4, and it'd just been even worse.
Yeah.
So by scaling the other one to that works. And then it's first quadrant.
Is this always just gonna be Joe's question?
I think so. I have to double check while I wrote it. Covers and solves, we get what? 500 here. The other one is 200 for the first one.
Wait, what do you do to find that?
Cover and solve. Just cover and solve
Understand
intersects.
that.
The other one is 200, 400.
I feel like I never know which like constraint to cover and solve.
It just go one at a time. It gives you your x and y intercepts. And then we have to find that point. Everything's moving inward again because we're less than or equal to.
Finding that point always confuses me.
Well, this one again, I'm going to use substitution because if you look at that first equation, don't I have b kind of almost by itself? So what I'm going to say is that b is 500 minus 2.5 OR. So 1.5 OR plus 3 times that is 600.
And you've got the 1.5. Oh.
Direct substitution here, so then we get 1.5 orange plus 1500 minus 7.5 orange is 600, which works out to wind up being 900 is 6 OR. So you have 150 quarts of ore. If I use 150 quarts of that one, then I subtract that out and I get 125 for the other.
How'd you go from it equaling B to equaling 600?
I'm using the system of equations again. I'm going back to here. I'm saying B is this. I'm just substituting it back to what we worked on all last week. That's the whole point of when we were doing all that stuff before. We keep that because I remember I kept saying we're gonna use this with some crackhead word problems. And then you go through your gamut of all your stuff, but the only trick on this one, it didn't ask how many quarts, it asked how many gallons. So your final result, did you get this far and not do it, Dad?
No, I didn't get anyone get it.
Oh.
Wait.
Hey.
No, that's not it.
Hey, look at that! We should have bet on the fact that they were going to mess up the bell schedule. No, we still got time. They did not turn off the regular bells because that would have been normal first hour over.
Oh.
I know you guys want to get out.
No.
We got another 8. We got another 8 minutes.
So,
So when you go through your test points, you've got your 0, 200, 150, 125, 200, and 0, and obviously 0, 0. When you test them all out, this one is the one that works, but the only thing that they ask you is how many gallons of each should you mix. You just divide those both by 4, and then gives you your final result. Because right now you're in quarts.
Wait, which part do you multiply by 4?
The very end here, you started out with 125 gallons,
Yep.
and everything else was in terms of quarts. convert the bigger to the smaller. It's just like when you're
Yeah, no, I know, but like when you finish your final, like when you get your final result, which part are we gonna multiply back to gallons?
Oh, the right here, your answer here is in quarts. You're gonna have 150 quarts of orange and 125 quarts of the berry.
Yeah.
So that means it would be divided by 4. So you
37.5, 31 point.
yeah, 37 and a half and 31 and a quarter is what you would wind
You
up.
have to put it back down.
Correct, because it asks you in terms of
Just like your,
quarts.
so just like your final point.
Yeah, that's all. That's about as crazy as that one gets. The last one is the weirdest of them all about tomatoes and sauces and stuff, because it gives you that one last bit where it says that you want to sell at least 3 times as many tomato sauces than salsa. So think of it this way: if you sell one salsa, how many should you sell of tomato? 3. So for every salsa purchase you have, you want to multiply it by, say, bless you, get up to the tomatoes. That's the trick on that one. It's nasty. It really is kind of nasty.
We have that on
The
tomorrow.
the profit of that one was, I think it said that you had, I wrote it down here, I didn't finish my graph yet.
I put 2t plus 1.5 and what should I make?
Oh my gosh.
I used S for salsa, but yeah, that's fine. You're right. That's
Oh,
exactly your
okay.
profit thing. That's perfect.
I got that far and then I stopped.
Now you go back and you have 2 parameters to worry about. You have so many tomatoes to work with and so many onions to work with. You have 180 tomatoes.
Wait, so then is it like 10t is less than or equal to 180?
Careful. You have to think of it in terms of, you have the mixture. The tomato sauce uses 10 tomatoes, but how many tomatoes does the salsa use? 5. So 10 in the tomato sauce plus 5 in the salsa has to be less or equal to 180.
Okay.
That's your restriction on the number of tomatoes you can use, okay? Then you do that again with the onions. You have 1 onion per tomato sauce plus a quarter onion per salsa, and you have up to 15 onions to use.
The tomato sauce and the salsa just like threw me off because I was like,
I know,
Like,
you know what, it's much easier. When I worded the ones that I made up for you guys for the quiz tomorrow, the ambiguity of the language, you don't have to worry about it. It makes sense in how it's written. I really try to not throw stuff like this at you. The the last one was the fact that you want to sell 3 times, or excuse me, for every salsa, you want 3 more tomato. So what's weird about that is you have to think of it this way. 3 times as many tomatoes equals the salsa. So you have to triple the salsa to equal a tomato. Does that make sense?
well, why is it greater than or equal to what? Should we just put?
Because it said at least. Okay. So that's the last one you throw in on the graph. Now, when we plot this one through, it's still cover and solve, cover and solve.
Wait, it said it should have at least 3 times as many?
Yeah.
So then shouldn't the sign be flipped? Shouldn't it be 3, like,
Well, if you sell 1 salsa, you want at least 3 more tomatoes. So every salsa you sell,
Oh.
you triple it, and you want it to be bigger at least, because it has to be bigger than that. So if you triple your salsa, you get your tomato.
I thought that you said for every tomato there needs to be at least 3 of the sauce.
And that's what we're getting, because if you triple the number of salsas you sell, that should
So
be.
then if there has to be at least 3 salsas, then wouldn't the 3 salsas be greater than or equal to?
Your tomatoes have to be, you want to be 3 times as many tomatoes greater than the salsa. So in order for it to work out, you have to triple it. And that's what's weird about this one.
I feel like, okay.
I know. So you know it's first quadrant. I don't have to put that one in. But let me just throw this together real quick and show you how that works with that one diagonal line going through. As we cover and solve, we'll call this our T for tomato, this one for our salsa, because that's how we started the problem. 18. And what's the other one then? 36. And we're moving inward. The other one is at 15 and 60. Is that right? Yeah.
Yeah.
So we have this intersection point. 1 tomato equals 15 minus a quarter salsa. Is it okay if I use that as a substitution at the real fast?
Yeah. So,
Because what I want to do is find that point first before I plot this one, because it'll help me figure out, is my line going to be above it or below it as I go through it? Okay. So 1 tomato is 15 minus 0.25 salsa. So 10 times 15 minus 0.25 salsa plus 5 salsa is 180. 150 minus, what is that? 2.5 plus 5, 80. Uh, 30 divided by 2.5 is 1 1/4. No. 12.5. Just 12.
Yeah.
That was close. So this is 12 for the S value, and quarter of 12 is how much? 3? So 15 minus 3 is 12, so it's at 12. Look at that. Yay. So now, when I do the next line of T has to be greater than 3 times S, is it going to be above that or below that? Let's go from there. No, what I'll do is I've got the dowel problem and the other one on the sheet here for you. If you guys want to grab it on your way out. And those two are a lot easier. No, I'll get these two for you tomorrow. Here, grab one on your way out. Do the dowel clothes and the breakfast bar are more along the lines of normalcy as opposed to the other ones. I am much nicer than Seb. You'll get there. Hopefully by tomorrow. Waiting patiently. Remember, try do the dowel close. How are you? Oh, sorry. That's fine. No problem. Welcome. No problem. Good times had by all. Yay. Hooray. All right. Yay! Huzzah! Don't hate math. Math is fun. I'm fantastic. I'm kind of hungry. I got up early today. I ate breakfast earlier than I normally would. You too.
Math is nothing but pain and suffering.
No, it's mental abuse to humans. Hey, never heard that before. Here are my friends. I know. Being a little facetious.
Mr. Murphy.
You too. Well, let's see. Alright. See you later.